Hey, 7th period algebra. Okay, here's lesson 2 on 7-2 multiplying and dividing rational expressions. Okay, it's pretty exciting. This is your very last new material for 8th grade algebra. Here we go. Okay, just like in the last video, we're going to start with a review of math. And remember, I told you rational expressions are fractions. So when we multiply fractions in math class, we take 5, 6 times 12/35. You were taught before you actually multiply, you actually try to reduce before you actually multiply across. We're going to do the same thing in the algebra. So let me just show you. I know everybody knows that 6 goes into 12 twice and 5 goes into 35 7 times. But again, let's take a step back and remember really what we're doing so that we can apply it to the algebra. So first of all, we're going to do the prime factorization of all these numbers. So 5 is just 5 times 1. 6 is 2 times 3. 12 is 2 times 2 times 3. And 35 is 7 times 5. Okay, so just like we did when we were reducing fractions in the last section, we're going to look and see, is there anything on top and bottom that we can reduce, cancel out. So we have a 2 on the bottom, 2 on the top. We've got a 3 on the bottom, we got a 3 on the top. We've got a 5 on the bottom, we got a 5 on the top. And that's it. So on the top we have 1 times 2 is 2. And on the bottom we have a 7. So 5, 6 times 12/35 ends up being 2 sevenths. Okay, just like we did multiplying review, let's also review what really happens when you do division of fractions. So technically what we do is we don't divide, we actually do 6/9 and we do it times the reciprocal, which means turn over the second fraction and make it 27/21. Okay, now we're going to follow the multiplication rules. So let's go ahead and do the prime factorization. 6 is 3 times 2. 9 is 3 times 3. 27 is 3 times 3 times 3. And 21 is 3 times 7. Okay, again, we're going to look and see, is there anything on top and bottom that I can cancel out? So we have a 3 here and a 3 here. I could cancel this 3 with this 3. I can cancel this 3 with this 3. And that's it. So now, what do we have on top? We have 2 times 3, and on the bottom we have 7. So we're going to go ahead and multiply out, and we get the answer of 6 sevenths. Okay, now let's see how this applies to rational expressions. So I have my first problem, negative 5a cubed over 3b cubed times 2b squared over 15a. So we're going to start with a problem that has just monomials in it. There's no binomials, there's no trinomials, or anything like that. So first thing we're going to do is we have to factor everything, just like we did with the math problem. So negative 5a cubed. Let's see, that's negative 1 times 5 times a. 3b cubed, 3 times b times b times b. 2b squared, 2 times b times b. And 15a is 5 times 3 times a. Okay, so we've factored everything. Now we're going to look for anything alike on the top and bottom that we can cancel out. So let's see here. I see we have an a alike, we have a b alike, we have another b alike, and that's it, because we can't cancel out the 3's on the bottom because they're not on top and bottom. So what do we have left on the top? We have a negative 1 times a 5 times a 2, so that's going to be negative 10. And on the bottom, also on the top, we have a times a, which is a squared. And on the bottom, we have 3 times 5 times 3, which is 45. And we have a b. Now, I just realized, and I can see it in my answer, that guess what? I have another thing that I have in common, and I just totally missed it, and it was they actually had a 5 in common back here. So I should have taken another 5 out. But if you notice in your final answer, I notice it there. I can go ahead and simplify there too. So I'll divide a 5 out of here, and that gives me a negative 2, and this gives me a 9. So my final answer is negative 2a squared over 9b. Now, while I didn't actually make that mistake on purpose, it's actually good to show you that you always want to ask yourself at the end of a problem, can I do anything else to simplify? Okay, so it was actually a good mistake to make so that you guys could see that this will happen to you eventually too. Okay, here's our next example. Now, if you noticed, we don't have monomials now. We have monomials and we have binomials. So the first thing we're going to do is we're going to factor everything. So we have to remember all of our factoring methods. So on the top, 6x plus 6. The only thing I notice is they have a common factor of 6, so I'm going to take it out. And I have 6 times x plus 1. 7, can't do anything to it. 14 is 2 times 7. And x squared minus 1 is the difference of two perfect squares. So I do x plus 1 times x minus 1. And it's very important that you make sure everything is factored completely, because again, if you don't, you won't notice there could be something in common and you may not actually see it. So I know I've factored everything out completely. So now I'm going to look on the top and bottom. Is there anything that I can cancel out and simplify? So first of all, I notice I have a 7 on the bottom and a 7 on the top. And then I notice that I have an x plus 1 and an x plus 1. Okay, so now what do I have left on top? I have a 6 times 2, which is 12. And on the bottom, I have just x minus 1. And you can just leave it in parentheses in the binomial. And that's it. There's nothing I can do. That's my final answer. Okay, so here we go. We have a new problem. 4x plus 8 over 7x squared minus 14 times 3x squared minus 5x minus 2 over 9x squared minus 1. So I see 3 binomials and I see a trinomial. So I have to figure out all my methods of factoring. I got to see what I can do. So 4x plus 8. I see they have a common factor, so I'm going to factor it out, and I get 4 times the quantity x plus 2. Can't do anything else to that. 7x squared minus 14. Well, I see a common factor of 7. So I'm going to make that 7 times the quantity x squared minus 2. And then I'm going to ask myself, can I factor x squared minus 2? Nope, it's not the difference of two perfect squares, so that's done. On the top right, 3x squared minus 5x minus 2. I'm going to try to factor that trinomial. And if I do 3x here, and I do x here, and I do a 1 and a 2, can I make a negative 5 in the middle? Yep, if I put a plus here and a minus here, so that's 1x and negative 6x, that's going to give me a negative 5x in the middle. And there's nothing else I can do to that. And then on the bottom, I have the difference of two perfect squares, so I have 3x plus 1 and 3x minus 1. Okay, so I've factored everything completely. So now I'm ready to say to myself, what can I cancel out? Or is there anything I can cancel out? Well, I see a 3x plus 1 and a 3x plus 1. Okay. And then I see an x squared minus 2 and an x minus 2. They're not the same. They look close, but there's nothing I can do, so I can't factor that out. 4 and 7, can't do anything there. I can't mark out the x's on the top and the bottom and the x plus 2 and the 3x minus 1. So that's it. That's my answer. So you could multiply it out, but you don't have to. So I would want you to write your answer as this. 4 times the quantity x plus 2 times x minus 2 over 7 times the quantity x squared minus 2 times 3x minus 1. And that's it. That's your final answer. I know it doesn't look like that's an answer, but that's it. There's nothing else I can do to it. Some teachers in high school may want you to actually multiply all that out on top and on the bottom, but I don't, because if you make a mistake in that part, then that's a problem too. So I just leave it in factored form and it's done. Okay, we're going to switch now. We're going to do division. All right, so first thing, you need to get into a routine here, because one of the most common mistakes in division is you will forget to change it to multiplying by the reciprocal. So if I were you, I would not try to factor everything and do the reciprocal all at the same time. So what I suggest is, first of all, go ahead and make sure you make it multiply by the reciprocal. Do that first. Don't even worry about factoring it, okay? Now we're ready to start factoring. So 7x squared, that's going to be 7 times x. 6 is 2 times 3. I'm going to change this multiplication sign to a dot just so we don't confuse ourselves. And then 2y, nothing I can do. And the x, nothing I can do. So now we're going to look and see on top and bottom, is there anything I can cancel out? I see an x and an x. I see a 2 and a 2. And I think that's it. So on the top I've got a 7, an x, and a y. So since it's multiplication, that's just 7xy. And on the bottom I have a 3. Done. Okay, so here's our next one. We've got 4 binomials. So like I said, get in a routine. First of all, let's flip things over. Let's not even worry about factoring. So my first fraction stays the same, 10x plus 4 over x squared minus 4 times, I'm going to flip this one over, x plus 2 over 5x cubed plus 2x squared. Now we know we've changed it to multiply by the reciprocal. Okay, now I'm ready to start factoring. Alright, so 10x plus 4. I see a common factor of 2. So I'm going to take a 2 out and I get 5x plus 2 on the inside. Okay, that's factored completely. X squared minus 4. Difference of two perfect squares. So x plus 2, x minus 2. X plus 2. Nothing I can do to it, so what I do is I put parentheses around it because I got to remember it's a binomial. 5x squared plus 2x squared. I see they have a common factor of x squared. And I get 5x plus 2 on the inside. And there's nothing else I can do there. Okay, now I'm ready to start looking. Is there anything that I can start marking out? Well, I see an x plus 2 and an x plus 2. I see a 5x plus 2 and a 5x plus 2. I cannot cancel out that 2 on the top and the 2 in the x minus 2 because one's a monomial, one's a binomial. So that's it. Nothing I can do. So my final answer is the top I have a 2. The bottom I have an x squared times x minus 2. And that's your final answer. Okay, one last one. So why don't you pause your video and try this one by yourself and then come back while I go over it and make sure we have the same thing. Alright, so first thing I'm going to do is I'm going to do the reciprocal. So 3x squared minus 10x plus 8 over 7x minus 14 times, flip this over, this is 21 and this is 9x minus 12. Okay, so now I'm ready to start all my factoring process. And no one says you have to do a certain one first. So I'm going to go over here and I'm going to do 21 first, 3 times 7. And then on the bottom, 7x minus 14, I see it's got a common factor of 7 times the quantity x minus 2. Over here, 9x minus 12, I see they have a common factor of 3, so it's 3x minus 4. I always like to start with the easy ones first. And then I have a trinomial. So let's try to do my trinomial. And I always use that on the bottom, the hint, the 3x minus 4, because chances are it's going to cancel out. So just, I like to be aware of what's around the problem because it may help me in the end. So let's try 3x and x. And obviously 8 is 4 and 2. And I'm going to try, since I have a 3x minus 4, I'm going to see does that actually work. And what if I do an x plus 2? Oh, it's not x plus 2. It can't be. So I'm going to grab my eraser and I'm going to make that. It's got to be a minus because it's got to be a positive 8. So negative 4 times negative 2 is positive 8. 3x times x is 3x squared. Negative 4x and negative 6x gives me negative 10x. So make sure you check your factoring because if it's not factored correctly, then you did all that for nothing. Okay, what can I cancel out? Let's see here. I have a 3x minus 4 on top, 3x minus 4 on the bottom. This is my favorite part. I like to cancel this stuff out. X minus 2 cancels out. I have a 7, and I have a 7. And I have a 3, and I have a 3. Everything cancels. So the question is, what's the answer? It is not 0. There is still a 1 everywhere. So your final answer to this problem is 1. And here's why it's a 1. Think about if you had a fraction and I said simplify the fraction 4 over 4. Well, that's 2 times 2 over 2 times 2. Doesn't everything cancel out? And isn't 4 over 4 equal to 1? So please understand that if everything cancels out, the answer is not 0, it's 1. Okay? All right, so hopefully that helped you with lesson 7 too. Now at this point, everything on your reviews you should be able to do unless it says graphing a radical. You don't have to worry about those. So go back and finish your reviews, and hopefully this helps. And there's a lot more examples in section 7.1 and 7.2 in your book if you want to refer to those for any more practice or any more sample problems. Good luck.